Hello, and welcome to Lessons with Laurie, where we look at some of the big ideas in the mathematics curriculum, kindergarten through grade 5. In this lesson, as well as the next, I'd like to talk about fractions, and in particular, computations with fractions, when we add, subtract, multiply, and divide fractions. I want students to learn mathematics with understanding, meaning I don't want them to simply memorize rules. I want them to understand the rules and why they make sense and how it is connected to other things that they've already done in mathematics. I've had students and actually a few adults who have said to me, you know, Laurie, why don't we simply add fractions this way? It would be a heck of a lot easier, meaning let's just add together the two numerators, let's add together the two denominators and get an answer of 2/7. Well, I grant you that it would be easier if we added fractions that way, but it doesn't make much sense. 2/7, if I think about a whole, 2/7 is less than 1/2. 1/4 plus 1/3, if I add together those two quantities, I'm going to get an answer that's greater than 1/2. So even by estimation, I know that my sum here should be greater than 1/2, and so I don't simply add the numerators and add the denominators. I needed to have a common unit, which we refer to in this case as a common denominator. When we add together two quantities, we are adding like units. For fractions, it's like denominators. Well, why do we need that? Well, think about this context here. If I wanted to add together 1/4, and you can see that I have that on the left side, to 1/3, the unit here is, or the whole here is 1 cup. I have 1/4 of a cup plus 1/3 of a cup. I can add them together, which means I would mix them. And if I wanted to talk about their sum, how much water I have now, I can see that my answer is greater than 1/2, but I can't name it. I don't know the name for my answer. I know that it's less than 1 cup, more than 1/2 cup, but I don't have a name. So addition can be done, but I don't have a name to give to that sum. One of the models that we use in 3rd grade is fraction strips, and we actually use them in 4th grade as well, along with several other models. When we add fractions and we do it with fraction strips, it might look like this. I have a model for 1/4 and a model for 1/3. You can see that I've taken the whole, divided into 4 equal parts, shaded one of them. The whole, divided into 3 equal parts, shaded one of them. Here is what my whole looks like. If I want to add together those two quantities, in this context, it would mean I would place the yellow strip at the end of the blue strip. So there's a model for 1/4 plus 1/3 more of this whole. And I can see from my model that it is indeed more than 1/2, but again, I don't know its name. So in 4th grade, because in 3rd grade we're drawing models, we're talking about unit fractions and counting unit fractions such as 1/3, 2/3, 3/3, 4/3, 5/3, and so on. In 4th grade, we then start to draw pictures of them and talk about equivalent fractions, a really important concept that precedes addition and subtraction of fractions. And so I would rename each of these with an equivalent fraction, meaning it has to have denominators which are alike. Well, if I were going to draw pictures of 1/3 and 1/4, I often use what's referred to as an area model. They're quick and easy for students to draw versus drawing a linear model. I like to use a square, an area model here. I have a square that I've divided into 4 equal parts, and I've shaded one of them. The same size unit, the whole here, I've divided into 3 equal parts, and I've shaded one of them. So I have 1/4 plus 1/3. Again, just like I did with the water or with the fraction strips, I could actually take scissors and cut out this 1/3 piece, rotate it, and put it over here next to the green piece and ask, what is that sum? I can see it with my eyes, but I can't name it without having a unit that is the same. So that's why in this area model, I've taken the whole, this large square, I've shaded the same quantity, that 1/4, but I've also put additional markings in here so that I've created 12 equal pieces here. So I've renamed my 1/4 as 3/12. My 1/3 I've redrawn, same amount is shaded, but I've drawn some additional vertical lines here so that I now have 4 of the 12 equal pieces shaded. So I can add, instead of thinking of 1/4 plus 1/3, I can rename it as 3/12 plus 4/12 would be 7/12. I'm adding together like units, and in this case, a common denominator of 12. Well, we actually do the same thing when we're adding whole numbers. If you were to add a 2 and a 3-digit number together, such as 45 plus 137, you would add the ones together, you would add the tens together, and then you would add that last 100. You add like place values. We add like units here. Even when we're adding money, we actually are using like units. I have 2 quarters and a dime here. This quarter is 1/4 of one whole dollar. It's a quarter plus 1/10 of a dollar. In order to add these together, if I think about fractions versus decimals, instead of thinking of this as 1/4, I could rename it as 25 100ths. The unit that I'm changing it to is actually pennies. 25 100ths plus 25 100ths plus 10 100ths would give me 60 100ths. So whether we're adding whole numbers, fractions, coins, which are our decimals, or in algebra, when we're adding together algebraic expressions, we need to have common units. I'd like to share with you just one last model which students find really interesting, so I wanted to be able to share that because many of you have egg cartons at home. So I have shaded 1/4 of a dozen here. I've put 3 tomatoes in there. You can see that it's 1/4 of the dozen. Here I've shaded 1/3 of the dozen. I've put in 4 tomatoes. If I want to add these two together, I now have 7 out of the 12. I have 7 tomatoes, which is 7/12. So 1/3 plus 1/4 is 7/12. So when we're adding fractions, we want to rename them using a common denominator. We need a common unit. So addition or subtraction involves like place values, like units. In the next lesson, we'll talk about multiplication of fractions. Thank you for being with me. See you next time.